Okay, for the following 3 weeks, the topic that we will be discussing is data modeling. So, before I give you a high level overview of what that journey will look like, let me try and first connect it to discussions that we have had so far. So, in the discussion that we've had so far, the example that I used to introduce our course was this airline reservation example where you have an end user, a customer sitting before a device, a laptop, making an airline reservation. And the data that is needed to support this particular business application is stored in the background. And without repeating some of the things that we discussed before, a couple of important points that we made in our previous discussion. First of all, the point that we made is a database, which is sitting in the background over here, is not just any haphazard collection of data, but it's a structured collection of data. And I kept emphasizing the word structure, and you will hear me mention this term over and over again throughout the course. It's the structure of the database that makes it special and makes it efficient, makes it effective. So we have to spend a good deal of time and effort understanding structure and understanding how to judge quality of the structure of the database and so forth. Okay, so the first point that we made was a database is a structured collection of data. And this thing in the middle, the database management system, is the software that lets you create that structure and manipulate that structure. Okay, that we know. So following that, a couple of additional points that we made in our previous discussion. One is we introduced the concept of a data model. And I said that that is simply a fancy term for describing the structure of the database. And it's not just a cosmetic issue. I made the point that I cannot describe the structure of a database in simple, plain English because that's just way too imprecise to implement anything on the computer. So we must have some precise way of describing the structure of the database. Okay? So that's what the data model will be. Okay. Now, data modeling, we also mentioned that data modeling is the process of coming up with the structure. Okay. Now, before I give you this high-level description of what the data modeling process looks like, what's the starting point, what's the end point, and what are the different milestones along the journey, let me give an analogy with which you might be familiar. So, if you're trying to build a house, you don't start off by thinking immediately about what size hinges you're going to use. Are you going to use 6-inch nails, 4-inch nails? Whether you're going to use triple pane window or double, not those kinds of nitty-gritty details. You start off at a fairly high level with some functional description of the house, basically what size house you want, how many square feet. Is it what style of house? Is it a ranch style, a colonial style? Do you want 4 bedrooms, 5 bedrooms? What style? Is it an open style? Do you want to deck? Those kinds of things. Okay, so a high level description, and then perhaps from that description of your requirements, you will sit down with, and you meaning the end user, in this case the owner of the house or the person building the house, would sit down with an architect or an engineer and develop a plan for the house. And even the plans for the house will not get into things like hinges and doors, door sizes and things. Well, they might get into door sizes, but not a whole lot of nitty-gritties. What size wire do you need? Do you need 12 gauge wire, 10 gauge? Not that kind of stuff. Okay, so those details will have to be hashed out. Otherwise, you can't build the house. But they come gradually. So the picture, I hope the picture that you're getting is that we start off with some understanding of the requirements, and then we gradually refine our way down to all the nitty-gritties, all the details that we need for implementation. Now, once I describe the data modeling journey that we will go through over the next 3 weeks, you will find very similar parallels. So we'll start off with requirements and then gradually work our way through more and more detailed levels of abstraction, and finally there will be an implementation on some machine. Okay, so that's sort of the analogy that I will draw. So let me turn next and describe for you this. So this data modeling journey, what might the starting point look like? What are different points along the journey, and what does the end product look like? So let's get an idea of that, and then we'll get into the data modeling process in actual a lot of detail. Okay, so usually in the data modeling process, the starting point is some understanding of the business application for which you want to develop the database. Okay, so continuing with the example that we have introduced the course with, this airline reservation example. So I'm showing you, in this case, a very, very simplified version of requirements in a textual narrative form. And in practice, the requirements would be given not just in textual form, there may be audio recordings, there may be video, there are all kinds of mixed ways, hybrid ways in which the requirements of the application will be stated to you. But for our purposes, for this course, this very simple description will suffice because it brings out the main points of the requirement that we need to focus on. Okay. So let me just read a couple of sentences here. It says our client needs a system to manage their daily operations. At the core, we must track our passengers and the specific flights they take. Since passengers can take many flights and each flight carries many customers, you will need to resolve this many-to-many relationship, etc., etc. Their reservation, and that flights are operated by our airplanes, and flights originate from and terminate at various airports, and so forth. Okay, so you can see various descriptions of different aspects of the application. So a couple of things that I want you to take away from this narrative. When you look at these requirements, you can see that immediately there are certain things, objects about the application, about which information will need to be stored in the database. For instance, just from this narrative, somehow the database must be able to store information on passengers, about passengers, who they are, what the date of birth is, name, address, things like that, credit card number perhaps. And then you need information on flights. Okay, what time does the flight leave? What time is it scheduled to arrive? Those kinds of details about flights. And then reservations that passengers make. Passengers make reservations on flights. Okay? So multiple passengers may make reservations on the same flight, and the one flight can have multiple passengers and so forth. And then, of course, in order to implement the flights, the airline would have to assign aircraft to the flights. Okay? So the first thing to take away from this narrative is that there are things, objects about which you need to store information. Now notice that not all these objects are physical things. For instance, airports are physical things. You can think about their properties. The airports have location, size, and things, how many runways they have, all those things. Passengers are physical things about which you can easily imagine what the properties might be about those things that you store information about. But there are things that are not necessarily physical. For instance, a reservation is not something physical that you can touch and feel, but a reservation is something about which you need to store information. For instance, the date of the reservation, what was the price charged for the ticket, things like that. Okay, so the first thing to come out of this narrative is that there are things about which the database needs to store information. The second thing that should have come out from this discussion is that there are relationships among these things. So these different things like passengers, flights, airplanes, reservations, they don't just hang in the database in isolation. They have relationships among them, meaning the content of these objects, they are related to one another. They're not unrelated. For instance, passengers take flights. They book flights. They book reservations on flights. Okay, so there's a relationship between passenger and reservation. There's a relationship between flight and reservation. There's a relationship between airplanes and flights. There's a relationship between flight and airplane. So not everything is related to everything else. So it's not a complete, mesh type relationship. But objects in the database will be related to one another. So this is another very important aspect of the narrative to take away from the description. This is usually, so this kind of requirements description is usually the starting point of the data modeling journey. Okay, so what happens next? So again, I'm not telling you the how. That's what the next three classes will be about, or the weeks will be about. But I'm just trying to show you what would be certain milestones in the process, in the data modeling process. So starting from that description that you just saw, the next step in the journey would be somehow analyzing that that narrative, and we will see what that analysis looks like, how one goes about doing that. We would try to describe the structure of the data in a graphical form. So the language that we are going to learn, that we are going to use to describe the structure of the database, in other words, the data model that we're going to develop, is what is called the entity relationship model. Is one of the most common methods of describing the structure of the database. Okay, so from the verbal narrative, the textual narrative, whatever the starting point of the journey, the first first milestone is what would be called the conceptual data model, the entity relationship model. So you can see it's a pictorial diagram. Okay, it's a pictorial representation of the structure of the database. Now, with any new language, you can you need when you're learning a new language, how do you start learning a new language? You learn the words, the rules of grammar, and so forth. So we need to do the same thing with an entity relationship diagram. Before I can draw a diagram like this, this is a graphical language, so I need to know the elements of the language. What are the nouns, what are the verbs, what's the alphabet like? So we will see what these boxes mean, we will see what these lines mean, we will see what these symbols on these lines mean. So everything, there's nothing redundant in the picture. Every element of the picture tells a story about the structure of the database. And as we start a discussion of data modeling, we will understand, we will learn what those different components are, what each of those mean. But one milestone is this conceptual model, the entity relationship model. This is a conceptual model. And what we mean by a conceptual, this logical model, is something, it's not, I'm not thinking about what disk drive do I need to use. I'm not thinking about anything physical at this point. Okay. So the next step from this conceptual model is what is called the physical model. How do I, this is like going from your house plan to plans for individual floors, and how do you connect one floor with another? Where does the staircase go? So you're getting gradually into more and more detail. So you can look at the diagram here in this second level. You can see this box called an airplane has had a lot of details filled out. Okay, this box called a flight has details filled out, and you can see lines between these boxes. Now, what are these lines? But remember, now when we discussed a narrative, we said one of the things that should come out from the narrative is that these things about which we are storing information, they're related to one another. Okay, so the relationships among these things, these objects, these so-called entities, have to be implemented in a certain way. So this is the physical model. And then finally, we have a step where we decide how each of these boxes, each of these components that have been identified, have been designed, get put on secondary storage. So that's another level of detail. In our course, we'll be really looking at this first level and the second level only. So I hope you understand what the data modeling journey looks like. It starts from an expression of requirements, goes through a logical modeling step where we extract the entities and the relationships among them, but represented in a way that is independent of the physical details of how they will be stored. Okay. And the next step, we have the physical model where we introduce more details, we fill in more details that help us with the final implementation. So the secondary storage, this last step, is something that we will not get into. This course is not a trivial process, of course. It's something that has to be done. But there are features in the database management system that helps us do that. So in this course, we will not get into this last translation. Okay, so we will look at the logical model and the physical model, and those two are the more difficult, much more difficult, and sort of a little more creative steps in the process. So I hope now you've gotten a sense of what the data modeling journey looks like, the starting point and the end point. Now, the next thing that we will start our discussion with, as I said, that any new language that we learn, we are about to learn a graphical language, in this case, the entity relationship model. We want to learn a graphical language to represent the structure of the database. And just like any language, we first, before you can write prose or before you can compose any songs, you need to know the symbols and how to put the symbols together, the rules of grammar. Otherwise, you won't be able to write anything. Okay, so same thing over here. Unless I know what these boxes mean, unless I know what these lines mean, unless I know what these refinements on the lines, these little symbols, crow's feet and straight lines that you're seeing, what do they mean? First, the symbol. What do the symbols mean? What are they used for? Why do I need them? Once we have all that grammar straightened out, then in the next 2 weeks, we will see how to string them together and go from requirements to the actual concept, the logical model, and then on to the physical model. So that's our plan. So for this week, the plan is simply to understand what are the different symbols that go into building an entity relationship model. Okay, so we will not, this week itself, we will not start from a grand description of an application and get to the actual design. We will discuss the building blocks that will help us do that. Okay, so just for our reminders, so the items that we'll be going through is what are the different symbols and of the entity relationship model. What do they mean? How do I describe relationships? And then we'll look at specific examples. Okay. So as you saw in the picture that we had, so going back to this picture that we used, this entity relationship model, this first picture that you see on top, it has certain boxes and lines. Okay, so if you think of the two letters ER model, entity relationship model, so there are two basic things that such a model represents. One are entities; these are things about which information is stored, data is stored. And then there are relationships, as I mentioned in the example, in the narrative example that we had, that these things, passengers, flights, airplanes, reservations, they are related to one another. Okay, so they are not isolated things about which information is being stored. So an entity relationship model employs two types of symbol. One is entities, and then the relationships between entities. Entities are usually represented by boxes. So let's see what they look like. So here we are taking a little more deeper look at entities. So when we want to, all we have said so far is entities are things about which data is stored. Let's get a little more precise. So typically entities, we use nouns to represent entities. For instance, people, places, things, events, and so forth. Now, anything about which you're storing information, any entity will have attributes. Okay, these are properties of the entity that are being stored, and you have to decide. This is a design decision. The attributes that you store about an entity, you have to make a decision. There's nothing predetermined about what those attributes might be. So just to give you an example, if I'm storing information as a student, so I as an individual are an entity. So in the university's database, I'm represented as a faculty member, and there are certain attributes of myself that the university as me as an entity that they would want to store. For instance, they would want to store my date of birth, my address, and so forth, the date I was hired, the date I was promoted, etc., etc. Okay, so there are certain attributes of myself that the university would be interested in as an entity. Now think of me, same entity somewhere else in a motor vehicle bureau, the DMV's database. It's the same me, but the properties of me that the DMV would be interested in are quite different. Okay, so obviously they'll be interested in my date of birth, my license number, traffic violations that I have. They couldn't be interested in the date I was hired at the university. That's of no interest to them. Okay, so the attributes of an entity that are recorded in a database depends on the requirements of the application. It is something you have to decide as a designer. Okay, so but from a definitional standpoint, what we are seeing here is one of the components of an entity relationship model is entities. These are things about which data information is stored. So typically we use nouns to name. Every entity must have a name, and every entity must have properties of the entity about which information is stored. And these properties are called attributes. Okay, So, for example, if you have a sales database, then an attribute for this entity called a sale could be the order number, the date of the sale, the total amount. There could be any other attributes, for instance, were there any discounts applied, so forth. Okay, so you can think of different attributes for entities, but the main point is the choice of attributes depends on the requirements of the application. What does the application, what kind of data about the entity does the application need? And the same entity in different applications may have different attributes recorded recorded about them. So visually, you can see this entity is represented by a box. Okay, the name, every entity must have a name. In an entity relationship diagram, you cannot have an entity without a name. Okay, so every entity must have a name, and as we said a couple of minutes ago, typically these names are nouns. Okay, now the properties of the entity, the attributes, are typically listed within the box, in a list. Okay, so for instance, in the case of the student, we have the name of the student. Sometimes this might be broken up into first name, last name. That's a design choice, whether you want to do it that way. You have address, date of birth, student ID number, and email. Okay, and you could think of other addresses, other attributes of the student as well. For instance, date that the student was admitted, the date the student graduated, perhaps. Okay, here is another entity called sale, and you can think of possible attributes for this entity called the sale. Now, if you think about that little diagram that we had discussed a few minutes back, let me go back to that. So this particular diagram, where I was describing the data modeling journey, I told you that the first milestone was this logical model, and then the second milestone in the journey was this physical model, where we gradually add more details to the logical model to help with implementation. Okay, so along those lines, coming back to here, conceptually, as you're developing the logical model, the entity relationship model, and you're identifying entities from the requirements description, you can think a little bit ahead, and you can think that each of these entities really will ultimately correspond to a table in the final database. So that's the direction in which we are headed. And these different attributes that you have about for an entity, these different attributes are the different columns of the tables. This is sort of what you can do a little look ahead, think ahead in terms of where we'll be ending up with these entities that are being created over here. So at this point, we need to make a slight distinction. Again, in terminology, we need to make a little bit of a distinction over here between two things, between an entity class and an entity instance. It is a fairly intuitive distinction, but we need to point that out. Okay, so an entity class refers to the entire set. So when we say student, this little box that you saw, this box called a student, or this box called a sale, actually, so let's focus on any one box, let's say student. Okay. This box called a student actually represents a whole bunch of students, not just one student in it, isn't it? Okay. So again, if we think of this box as a table, the box itself represents the whole table, and you'll have multiple rows in the table, so each row corresponding to one particular student. So there's a difference between the box and what the box holds. Okay. So we make a little distinction between entity class and entity instance. So entity class refers to the entire set, and entity instance is a specific occurrence of an entity within that class. Okay. So coming back to this, so this entity called a sale, that would be the entity itself, entity class, and an entity instance would be one particular sale, one particular order number, what the date of that sale is, and total amount of that sale. Okay, so I hope the distinction between entity class and entity instance is clear. So we can see a specific example here. So we have this entity class called item. So you have the item number, description, cost, list price, and so it's an perhaps being used for inventory control, how many units we have on hand. And here are two instances of that class. So item number 1 and item number 2. So item 1100 and item 2000. In the if you think of the mapping to a table, so the item is this entire table itself, the whole table, and these two instances, each instance is a row in the table. So the second instance is the second row. Okay, and if you look at the columns, these columns are the different attributes. Okay, I think the mapping should be fairly intuitively obvious. Okay, but I hope the distinction between these two terms, entity class and entity instance, is clear. Most of the time, when we go through the discussion this rest of this week and this lecture and the subsequent one, you will hear me use the word entity. Okay, but I think the context would make it clear whether I'm talking about an entity class or an entity instance. So in every point in our discussion, I will not be saying entity class or entity instance, but remember the distinction between these two, and where it is necessary to point out that distinction in our discussion, I will certainly do so. But there are these two aspects to an entity class and entity instance. Okay, now we come to the second piece of a major conceptual piece in an entity relationship model, and that is R, the letter R, relationship. And relationships are shown by a line connecting the entity sets. And notice that we said over here entity sets. Okay, so it's a line connecting the entities. So these boxes that are entities, lines connecting them represent relationships. Okay. Now, I think very earlier on in our discussion, we said that when we're discussing the narrative for the airline reservation system, I pointed out that entities are things about which we store information in the database. And I had also mentioned that these things don't hang by themselves, that their contents are related, just like passengers make reservations. So the content of reservations doesn't sit by itself. They are connected to passengers. Okay, so relationships really reflect the fact that the content in different tables, the content in different entities, they are related to one another, and this relationship is represented by a line in an entity relationship. Also, these lines must have names to them. So all relationships are given names. And remember, we said that entities are usually given nouns. The names they are given are usually nouns. By the same token, the names that are given to relationships are usually verbs. We like to use verbs to represent the relationship. Okay, because what does one have to do with the other? For instance, customer places orders. Okay, so places is a verb. Authors write books. Okay. If you think of it in the other direction, books are written by authors. Student enrolls in course. I hope you get a sense of why this is not just a cosmetic thing. Why are we putting names on relationships? Why not just have a line? What's the point in having a name on relationships? The reason you have to give names to relationships is because there can be more than one relationship between the same two entities. So, for instance, here, let's take these two entities, student and course. A very natural relationship between these two entities is that students enroll in courses. That's a very natural relationship, all right? However, if this student happens to be a graduate student, this graduate student could also be a TA for a course, okay? So you could have, let me see if I can pick a different pen here. So let me pick a pen. All right, so you could have a relationship between these two. You have a student is a TA for a course, and obviously, if I ask what courses is student X, let's say I have a student X, and I ask the question, what courses is this student enrolled in? I'll get a list of courses. But if I ask, what courses does this student TA, I might get a different list, okay? So you could have different relationships between the same two entities, and that is why it's important to name relationships. Otherwise, if I just drew two lines between the same two entities, and I just had two lines between these two entities. That would be very, very confusing, wouldn't it? So it's absolutely critical to have names given to the relationships. All right, so we have the two major pieces of the entity relationship model. We are learning the language now, the graphical language. What symbols are we going to see in an entity relationship model, and what do those symbols mean? So far what we've seen is entities are represented by boxes and relationships by lines. We had a little more refinement of entities. Entities have attributes, and they're listed as names within the entity itself. And there are two aspects to entities: entity class and entity instance. Okay, all right. So we can continue. Let's continue with the discussion now. And relationships are represented by lines. Relationships typically are given names that are verbs, and all relationships must be given names. And we had a little discussion of why it's important to give names to relationships. Now we have to get into a little more detail about relationships. All relationships are not created equal. So just drawing a line between two boxes will not tell the whole story. So if I see two lines, let's say I have two separate entities and I see two lines for two separate relationships, and I just leave it at that, that may not tell the whole story. So there are two aspects to relationships, so you're going to see more symbols now, okay, to refine our understanding of relationships. And there are two aspects of relationships that are important to us. One is cardinality, and the other is degree. So let's first try to understand why all relationships, rather how all relationships are not created equal. Let's go back to our airline example and see why that might be the case, and then we'll come back here and formalize that particular discussion. So here's that narrative again. Okay, so let's look at some of the entities that we mentioned: passengers, flights, reservations, airplanes, and so forth. So let's look at some of these relationships. So if you look at the relationship between flights and passengers, these two entities, just think about what the nature, a little more in-depth examination of that relationship. Now, one passenger can make a reservation on multiple flights, isn't it? They make a reservation on one flight. They might make a reservation on 3 different flights. So one passenger could make a reservation on multiple flights. Okay. Similarly, if I focus on any one flight could have reservations from one passenger. One flight could have reservations from multiple passengers. So that's one type of relationship. You see, this is what's called a many-to-many relationship. All right. However, if I look at the relationship between flight and airplanes, it's not quite the same. Okay. For example, one airplane could be related to multiple flights. For instance, if I take a particular serial number of an aircraft that United Airlines had, today it's going on a flight from, let's say, Washington D.C. to San Francisco, and that evening or the following day, it might go on a flight from San Francisco to Chicago. Okay, so one airplane could be related, associated with, could be linked to multiple flights. But if I look at any one flight, obviously there are not going to be more than one airplane assigned to the same flight. So one flight is associated with exactly one airplane. So I hope you see that when I think about these two different relationships, they're not quite the same. Okay, they are related, but they're not quite the same. Okay. So somehow I need additional symbols. So just drawing a line between the entity passengers and the entity flights, and drawing a line between the entity flight and the entity airplane, it will not tell the whole story. So in addition to that single line that connects the two boxes, I need additional symbol that tells me the more detailed story, gives me a better idea, a more accurate idea of the relationships between these entities. Otherwise, when it comes to implementation, I will make a mess of them. I will not have a correct implementation. Okay, coming back now to this slide that we had, where we had started discussing little more details about the relationship, namely cardinality and degree. We can formalize that informal discussion that we just had. So in terms of cardinality, so this definition of what is cardinality? It's an aspect of a relationship. It's a property of a relationship. It says the maximum number of related entity instances in the other. For each entity instance in one set, the minimum number and the maximum number. Okay. So let's take the little example that we had. Let me get the pen over here. So we had a passenger and we had flight. Okay. And up to now, the symbols that we have learned up to now is that a relationship is represented by a line between two entities. So I've just drawn a line between passenger and flight to represent the fact that the information in passengers and the information in flights are related. Passengers take flights, okay, or they book flights. But let's look at what we mean by cardinality. It defines the association between entity instances of the entity set. Okay, so for each entity instance, that means for each passenger, what is the minimum number of the other instances? So for each passenger, how they can book how many flights, minimum, and maximum how many flights. Okay, now we can have a passenger who's registered with the airline, but they haven't booked any flights yet. Okay, so one could make the argument that the minimum number of flights that a passenger can book is 0. Okay? And the maximum number, theoretically, the maximum number of flights that the passenger may book is infinite. Okay, but let's say, as a practical matter, maybe no more than 5 or 6. But in any case, the maximum number of flights, that a passenger can book is many. Okay, so you will see later on in a few minutes that the way we represent it symbolically is with these symbols. 0 means the passenger may book at the minimum 0 flights and the most many flights. This symbol that you see over here is known as a crow's foot because it looks like a crow's foot. Some people say that this is just a distorted M. This is a distorted letter M. Okay, my recording got interrupted as I was doing it, so I'm going to continue from where the interruption occurred. I'm going to try and splice the two sections back, but in case I'm not able to do that, I wanted to give an explanation of why I'm starting in the middle. So this is the slide at which the interruption occurred, and the discussion that we were having was that of cardinality. It's one of the properties of a relationship. So the example that I used was that we have this entity called passenger and then flight. This was drawn from the narrative that we are using for our discussion here. And to explain this concept of cardinality, the point that we made was cardinality defines the association between entity instances. Remember that little distinction that we drew between entity class and entity instance. Okay, so cardinality defines the association between entity instances of the entity set. So we have two entity sets over here, passenger and flight. So cardinality expresses the relationship between instances of these two classes. So one passenger, just before the interruption, excuse me, the discussion that we were having was that one passenger at a minimum could book 0 flights, so they have just entered into the system, but they haven't booked any flights yet, and at maximum could book multiple flights. So 0 and at most many. And you will see later on that the symbols that I used are 0 and this crow's foot. Okay, and the point that I was making is this crow's foot is sometimes referred to as a distorted version of many. So if you think of the letter M and you put it sideways and twist it around a little bit, it looks like this crow's foot. Okay. Now, if we think of these two other entities that we had talked about in the narrative, one is between airplane, aircraft, and flight. So we would have a line between these two entity classes because there's a relationship between the two. But if you think of a flight, if you think of one flight, that is, I'm taking one instance of the entity class flight. So at most, it should be associated with one aircraft. You can't have multiple aircraft going on the same flight. Okay, so at the least, a flight should be associated with one aircraft, one instance of one particular aircraft, and at most also a flight should be associated with one aircraft. Okay, so you can see different types of cardinalities in the relationship. So all that we need to know for now is that just drawing a line between two entity classes is not enough to express the full richness or the detail of the association between those two entities. So if you dig a little deeper into the two entities here and look at the instances of the entities, then two entities, the instances of each could have different types of relationships between them, and that is represented by the cardinalities. So let us have a little more in-depth look at the minimum and the maximum. Those are the two aspects of the cardinalities. That's what we're going to represent pictorially. Okay, we had two examples, different examples that we used here from the airline reservation example that we are using. So two separate relationships, one between passenger and flight, the other between aircraft and flight. In one case, you saw that you have at least zero and at most many instances can be related with one passenger. In the other example, one instance of the class, namely one particular flight, one instance of flight is related with at least one and at most one instance of aircraft. So this concept of cardinalities is an aspect of relationship, and it tries to express how instances of the entities are related to one another. Continuing now with the discussion that we had just a minute ago. So I've just redrawn those two pictures, the two examples that we used. One was the relationship between the entity passenger and the entity flight. And the second was the relationship between the entity aircraft and the entity flight. And when we look at the instances of each of these entities, namely we dig a little deeper and look at one instance of a passenger. That's what cardinality is all about, looking at instances of entity. So we said one passenger could book at least zero flights and at most many flights. Similarly, when we looked at the second example, one instance of flight, remember as we said, cardinality is all about relationship between instances of entity classes. So I pick one particular flight, that's an instance of the entity class flight. One flight is associated with at least one aircraft and at most one aircraft, right? So this first type of relationship here, where one passenger could be associated with at least zero and at most many, at least zero flights, this is called an optional relationship. So the minimum cardinality is zero. So it is optional for a passenger to book a flight. So the passenger exists in the reservation system, but they haven't booked a flight. So the relationship between passenger and flight is optional. Okay. Now, if you look at the second one, a flight better have an aircraft assigned to it. So this is what's called a mandatory relationship, a minimum cardinality of one. Okay, so just more definitions. Okay, so the symbols that you're seeing, you have a circle, you have the crow's foot, and you have the vertical line. They represent relationship between instances of the entities. When the minimum cardinality is zero, the relationship is called optional. So the relationship between passenger and flight is optional. A passenger may book zero flights at most, at least zero flights. Similarly, for the case of flight, a flight must be associated with at least one aircraft, okay, and at most one aircraft in this case. So when you have a minimum cardinality of one, the relationship is called mandatory. So the relationship between flight and aircraft is said to be mandatory. So these are terms. So when you see an entity relationship diagram, or you see a discussion of an entity relationship diagram, or you see a narrative that goes along with an entity relationship diagram, and you see such and such a relationship is described as mandatory, or such and such a relationship is described as optional, then you immediately know what that says about the association between instances of those entities. So here are some more examples of what we refer to as minimum of cardinality, talking about the minimum cardinalities. So you have a relationship between customer and order. Okay. So each customer places a minimum of 0 orders. It's quite possible that you have a customer who is registered with a particular seller, but they haven't placed any orders yet. So the customer exists, but they haven't placed any orders yet. So it's reasonable that to assume that a business situation is a case where a customer, at the least, so one customer. So just think about the language that I'm using. I'm saying one customer. So I'm looking at an instance of the entity class. So one customer places at least 0 orders. That's the minimum number of orders that they can place. Similarly, the relationship between author and book, you could have an author in a publisher's database, a potential author, so they haven't. So each author, so I'm looking at one instance of the entity class author, one author writes at minimum 0 books. Minimum 0 books, okay? It's a minimum cardinality. So remember, so just again, I'm repeating what we said a few minutes back. Cardinality expresses relationship between instances of entities. So just think about again the language that I'm using. One author writes a minimum of 0 books. So the minimum cardinality is 0. So the relationship between customer and order is optional. The relationship between author and book is also optional. Similarly, student and course, you could have a student who's registered with the university, has joined the university, but they haven't yet signed up for any courses. So each student, so notice one student, each student, I'm thinking about one instance of the entity class student, one student enrolls in at least 0 courses. So they may not have enrolled in any courses. Okay? So all of these three relationships are optional. All right. So a minimum cardinality of 0 in each of these cases. Okay. Now, it's possible that a publisher could have a rule that says that I'm not going to put you in my database unless you at least publish a book with me. Okay, or write a book with me. All right. In that case, then we would say an author would write a minimum of 1 book. So whether a minimum cardinality is 0 or 1, whether a minimum cardinality is optional or mandatory, depends on the business circumstances. Different organizations have different rules. That is why it is so important to be able to know details of the business circumstances. All right. In order to have an accurate entity relationship diagram that reflects the information requirements of the particular application. Okay. Now let's talk about maximum cardinalities. Again, to repeat, cardinalities have to do with instances of an entity class. So I use the same 2 examples that I've been discussing so far in my hand-drawn example. So we have relationship between flight and passenger and between flight and aircraft. So think of this second symbol over here, this crow's foot, this symbol over here. So one passenger can book at most many flights. So the maximum cardinality is many. Okay, so one passenger can book many flights. Now, if you think of the other second example between flight and aircraft, one flight is assigned to at most one aircraft. Obviously, multiple aircraft cannot fly the same flight. Okay, so one flight is associated with the maximum of one aircraft. So this is an example where the maximum cardinality is 1. So the maximum cardinality, the allowed choices are 1 or many. So now if I summarize this discussion about cardinalities, you can see that these cardinalities are represented by additional symbols that are added on to the lines. A line represents a relationship between 2 entities, and we put some more symbols along into the lines to express the cardinalities, because we've seen that even though a line tells us that two entities are related, there is more to that relationship than just the fact that just saying that the two are related. There are different types of relationships, and that's why the cardinalities that's where the cardinalities come in. And we have talked about minimum and maximum cardinalities, and you've seen some of the symbols that are used. Okay, so let's look at some more. So the same three, continuing with the same three examples that we had used before. So the maximum cardinality using those three. So one customer. So again, just pay attention to the language that I'm using. I'm saying one customer, or each customer, places at most many orders. So the maximum cardinality is many in this case. So one author writes at most many books. The maximum cardinality is many over here. One student enrolls in many courses. So the maximum cardinality is M over here. Okay, so this coming up with this maximum cardinalities and minimum cardinalities, how does one come up with these? How does one identify these cardinalities? You have to know something about the application. So you have to be a domain expert. Typically, what happens is the domain, you would talk to your clients, you would talk to the domain expert, you meaning the database designer, and by talking with the business application people, the people that actually run the business, they will tell you the rules of the business, how the business is run. Okay. Now, in the case of relationship between customer and order, I don't really need to talk to a company to know that. You have enough practical experience to decide that one customer can place multiple orders at maximum. That is how businesses operate. It would be really weird if one customer at most can place only one order. Okay, I suppose there could be some strange situation where that might happen. There is some regulation, there is some government regulation that say you can't order more than one of these things. But that means you would need to know that detail about the business. So the point I'm making is that cardinalities are an important aspect of relationships between entities. Okay, and cardinalities tell you the association between instances of entities. What the cardinality, there's a minimum cardinality and there's a maximum cardinality. How to identify those minimum and maximum cardinalities, you would need to know something about how the business operates. Now, these three examples that I'm using, seeing here, are so common, and all of us are familiar with these applications that we don't really need to think deeper as to what the cardinalities would be. For instance, I don't need to really go to a university and talk to students and talk to the university registrar to know that one student can enroll in at most many courses. That's how any university operates. Okay, but the fact that I wrote a many over here stems from my knowledge of how students enroll in universities. So the bottom line is the cardinalities are determined by knowing something about the business application for which you're trying to develop the data model. Okay. Now, if we combine the minimum and maximum cardinalities, how do we express in Word? In a couple of minutes, we will draw it in pictures. Ultimately, an entity relationship diagram is a picture. Okay, we'll get to the picture in a minute. But before that, write it in expressing it in narrative form. If I combine the discussion that we've just had about minimum and maximum cardinalities, for these three examples, how would we write it? We would say that each customer places at least 0 orders and at most many orders. So the minimum and maximum cardinalities are being expressed in narrative form in this sentence. Okay. If you go in the reverse direction, each order is placed by at least one and at most one customer. Do you see in the reverse direction? Okay. So in going from customer to order, one customer places at least 0 and at most many orders. Okay. When you go in the reverse direction, one order is placed by at least one customer and at most one customer. Now, think about the reverse, what I just said in the reverse direction, that each order is placed by a minimum of one customer and a maximum of one customer. Now, this is nothing sacred about it. Why did I say this? This is my assumption. This is how most orders are placed that I know about. You know, if I place an order, I am placing an order. One individual places an order. However, I can think of special circumstances where one order is placed by at least one customer, but at most multiple customers. For instance, when I go to buy a car, you could have joint ownership of a car. Two persons could buy a car, right? So if in a special situation, if this application for which you're developing the data model is an automobile dealership, then it's possible that one order is placed by at least one customer and at most many customers. Okay, so again, why am I going into such variations of these examples? Just to emphasize to you that cardinality is an important aspect of a relationship, but to determine the cardinalities, you need to know something about the business application. In other words, it is not a God-given truth that if you go from order to customer, the minimum number of minimum cardinality is one and the maximum cardinality is one. That is probably what it will be in most of the example, but you can think of special circumstances or specific example where that need not be the case. You have to know the application. Okay. So going on to the second example over here, each author going from author to books in that direction, one author writes a minimum of 0 and a maximum of many books. If you go in the reverse direction, one book is written by at least one author and a maximum of many authors. How did I know that it's written by a maximum of many authors? Because we all read books and we've seen that there are lots and lots and lots of examples of books that are written by multiple authors. That happens, and that's allowed. That's a normal course. It would be very odd if each book is written by at most one author. Again, I suppose there could be special circumstances, special organization for which only one author is allowed. But I really can't think of one off the top of my head at the moment. But if it were, then the maximum would be one. Again, the point here is I need to know something about the application in order to determine the cardinality. I need to know the cardinalities, but I will find that, I will determine that, I will identify that by knowing about the business. I can't determine it in a vacuum. Okay. Same thing, same logic. Let's come to the third example. Each student enrolls in a minimum of 0 courses and a maximum of many courses. Now, I suppose you could have a university that has a rule that in order to be a student at the university, you have to enroll in at least one course. If that's the rule at the university, then we would say each student enrolls in a minimum of one course and a maximum of many courses. Again, do you see that I need to know something about the business, about the organization, in order to find out the cardinality? There are not sort of universal truths, okay? Now, if I go in the reverse direction, each course is enrolled by a minimum of 0 students. So I could have a course that has no students in it yet, and the maximum is many. All right. So I hope you get a sense of what are cardinalities? These are aspects of relationships, and how does one identify cardinalities? Okay, you have to know something about the business. All right. Okay, now let's get to the picture. So we had narrative discussions of what we mean by cardinalities. How do I show it in the ER diagram? After all, the ER diagram is a picture. I need pictorial symbols to show it. So the symbols that we use are a 0 for cardinality, 1 for cardinalities, and the crow's foot. So these are the 3 symbols that are used to show different types of cardinalities. So let's see how these symbols would be used to represent these cardinalities that we just described, that we just discussed in words. If I had to put it in pictures in the ER diagram, what would that picture look like? Okay, so now how would we use those 3 symbols, the 3 symbols that we just discussed a minute ago? Let me use the red NOV. Okay, so these three symbols that we used a minute ago, how would we represent the narrative? So we had the narrative discussion again a little while back. So how do we translate this narrative to pictures in the ER diagram using these three symbols that you're just seeing over here? Okay, so the relationship between customer and orders, let me pick the laser point. So the relationship between customer and order, we described it in words already. So let me just translate the picture. So let's focus on this end over here. Okay. So one customer places a minimum of 0 orders and a maximum of many orders. All right. I hope you're seeing which one is the minimum and which one is the maximum. The inner symbol is the minimum and the outer symbol is the maximum cardinality. So let me repeat that. One customer places at least 0 orders and at most many orders. Now let's go in the reverse direction. One order is placed by at least one customer and at most one customer. So do you see it's the same sequence in which we are going? The inner symbol, inner meaning, if I think of the line that represents the relationship between the two entities, the cardinalities are symbols that are put on the line. The inner symbol represents the minimum cardinality and the outer symbol, the maximum cardinality. And you go from the instance that you're looking at to the opposite end to get the to identify the cardinality. So let me repeat. One order, that's the language in which you express it. Remember, cardinalities express relationships between instances of the entities. So one order, and it's helpful to express it in that language. One order is placed by at least one customer, that's the inner symbol, and at most one customer, that's the outer symbol. So one customer places at least 0 orders, that's the inner symbol, and at most many orders, that's the outer symbol. So let's go to the second example between author and books. One author writes at least 0 books, at most many books. One book, start from the other end, one book is written by at least one author. Obviously, you can't have a book without an author. So one book is written by at least one author. That's the minimum cardinality. That's the inner symbol. And written by at most many authors. That's the outer symbol, the maximum cardinality. Now, let's look at the relationship between student and course. One student, again, I keep repeating myself, but it's important. So cardinalities express the relationship between instances of entity. So it helps to start the narrative by saying one student rather than student. So one student is an instance of student. One student enrolls in at least 0 courses and at most many courses. One course enrolls at least 0 students, at most many students. I hope you saw how the symbols are used, symbols for cardinality are used, where the symbols are placed, the significance of the position of the symbol. What does the inner symbol mean? What does the outer symbol mean? Okay. So if I want to determine the cardinality from author to book, I have to look at the cardinalities next to book. If I want going in the reverse direction, from book to author, the cardinalities are found adjacent to author. Okay? So it takes a little practice, but I hope you got the mapping from narrative to symbols for entities as well as for relationships. All right, so now that we have identified cardinalities, we have defined what cardinalities are, let's close out our discussion for this week by identifying 3 different types of relationships. Remember, we said that we represent relationships between 2 entities by lines, okay? And then to get further in depth, the cardinalities tell us the relationship between instances of the entities, okay? Now, if we focus only on the maximum cardinality, so I look at the outer symbol on one end and I look at the outer symbol at the other end. Okay, so let's look at this picture in words. You should be able to translate that in words, what this picture is saying. So one employee manages at least 0 offices. So not all employees are managers. So one employee manages at least 0 offices and at most 1 office. Okay. Now, why is that the case? That's the rule of this particular organization. In this organization, one employee is not allowed to manage more than 1 office. Okay. It's entirely possible that you have an organization or a business where one employee is allowed to manage more than 1 office. Okay. In that case, this diagram would not be correct. All right. But given that the diagram is the way it is, the way I translate the diagram into words is that one employee manages at least 0 and at most 1 office. Now, if you go in the reverse direction, 1 office is managed by at least 1 and at most 1 employee. All right. So if you have an office must have a manager employee. That's what this picture is saying. Okay. Now, when I look at this picture as a whole, let's focus only on the maximum cardinalities on either side. So I focus on this outer symbol and this outer symbol. So do you see it's a 1 and a 1 on the 2 outer symbols? This is what is called a 1-to-1 relationship. So the maximum cardinalities are 1 on both sides. So this is what is called a 1-to-1 relationship. Okay. So now the second type of relationship that we can have, let's look at this particular example. So here what this picture is telling me, the way I would try, if I saw this picture in front of me in an ER diagram and I had to put this into words in my mind, how would I translate it? I would say that one faculty member teaches at least 0 offerings and at most many offerings. Why at least 0? There could be, now this could be a research university, so you could have some faculty who are not teaching anything, or the faculty member could be an administrator, so they're doing administrative duties, they're not teaching anything. So one faculty member, again, notice the language, I'm identifying an instance of faculty, so I'm saying one faculty member teaches at least 0 and at most many offerings, okay, an offering of a course. Okay. So if I go in the reverse direction, one offering, notice that this is a course offering in a particular semester or what have you, like MIS 310 section 3, that's an offering. Okay. So one offering is taught by at least one faculty member and at most one faculty member. Now, the at least makes sense. Obviously, if you have an offering, it needs a teacher, so there's at least one faculty member. All right. But this at most one depends on the university. If this diagram is a true representation of the university that it's referring to, then what it means is this university does not allow team teaching of courses. If a university allows a course offering to be team taught, then one offering could be taught by at most multiple faculty, isn't it? Then this diagram would not be correct. So if this diagram is a correct reflection of reality of what's happening in the business application, then what this is saying is one offering of a course is taught by at least one, but at most one faculty. That's what this is saying. Okay. Now, if I look at the maximum cardinalities on these relationships, so there are 2 sides to the relationship. If I look at each side and I look at the maximum cardinality on each side, so the outer symbol and the outer symbol. The outer symbol is 1 and the outer symbol is many. In this case, this is what is called a 1-to-many relationship. That's the second type of relationship that you can have. Okay. Now, let's look at the third one. Okay, here you have student and offering. So continuing this in the same vein, one student enrolls in at least 0 offerings and at most many offerings. That's what these 2 cardinalities mean. If I go in the reverse direction, one offering enrolls at least 0 students and at most many students. Again, all right? So this could be again, assuming that this is an accurate reflection of what the university, how the university operates, then if I look at the two outer cardinalities, the maximum cardinality. So here are the two cardinalities: minimum, maximum at one end, minimum, maximum at the other end. If I look at the two maximum cardinality, it's many, and many. The two maximum cardinalities are many, many. This is what is called a many-to-many relationship. And if you remember, let me see if I pick up the pen. A similar type of relationship we had between passenger and flights in that airline reservation example that we had. Okay, so one passenger can book at least 0 and at most many flights, and one flight could be booked by at least 0 and at most many passengers. So this was an example of a many-to-many relationship. So if I look at the maximum cardinalities between between two entities, then there are three types. Those relationships fall into three types: one-to-one, one-to-many, and many-to-many. Why is it important to identify these three different types of relationships? If you go back to our initial journey, so based on the cardinalities of the relationship between two entities, the it can fall into one of three categories we've seen: one-to-one, one-to-many, many-to-many. So there are three different types of relationships. Now, why is it important to identify these different types of relationships? If we go back to the data modeling journey, let's go back a few slides towards the beginning. Let's see here. Yeah, so this was the diagram right at the beginning of our discussion here. So I'll pick up the pointer here. So in terms of identifying the relationships, when we go from the logical model, so we have the entities and the relationships being drawn. We haven't yet discussed how to come up with this diagram. All that we're doing now is identifying the different symbols that are used in drawing the diagram. And we are identifying different building blocks now. So we identified entities, we said, okay, they are relationships. Then we went on to say that there are aspects of relationships called cardinalities. Based on that, we identified three different types of relationships and so forth. And the discussion we are having now is, why is it so important to be able to identify these three different types of relationships: one-to-one, one-to-many, many-to-many? It's because it affects the way you translate to the next stage, that is going from the logical model to the physical model of the data model. That's where in the translation you will see, again, this is something that will need to wait till a subsequent lecture, but the process of going from the logical model to the physical model, that's where the difference among the three different types of relationships will play a role. So those details will come later, but again, using our building analogy, going from a building plan that an architect has made to actual detailed drawings or detailed physical details about how each bedroom, the kitchen and drawing room and so forth will be laid out. That's the transition that we're talking about, going from a conceptual, a logical model, which is independent of any device on which the database will be stored, making the transition from that model to something that is a little closer to implementation, the physical model. That's where the identification of those different types of relationships will play a role. They'll be implemented differently. Okay, so it's important to understand the distinction among the three different types of relationships, how the implementation is done, and how the implementation of each of those three types of relationships varies. That we will discuss later. For now, it will suffice to know that there are these different types of relationships that can arise in practice when you're trying to go from a narrative to the logical model. So in the process of building the data model, knowing that there are these different types of relationships is important, because it helps us capture reality aspects of the business application that need to be represented in the data model itself. Okay, to summarize our discussion in this lecture, what are the things that we have learned here? Uh, One of the things that we learned is that the tool that we are going to use to represent a data model is the entity relationship diagram. Okay, and we talked a little bit about the data modeling process. That is, what are the different stages of coming up with the structure of the database. We typically start from a narrative or some description about the information needs about the application. And from that, somehow, we haven't discussed that somehow yet, we come up with a logical model of the structure of the database. And the language that we're using to express that logical model is a graphical language called the entity relationship diagram. And as part of that journey of the data modeling process, we said that after the logical model is developed, the next step is to build a physical model that is little closer to implementation. And some subsequently down the line, a couple of classes from now, we'll see how the translation takes place. But for now, for this lecture, we focus our attention primarily on this entity relationship model. What are the symbols that are used? So we talked about entities, which are represented by boxes, and then there are properties of entities called attributes that define what are the characteristics that are stored about each entity. Then we talked about relationships. Entities have relationships among themselves. And we went on to discuss properties of relationships called cardinalities. And based on the three different types of cardinalities that we identified, one to one, one to many, that depending on the three different types of relationships, the implementation in the next stage, that is going on to the physical model, will vary. Okay, and that those different types of relationships are sort of the starting point in terms of the translating the logical model to the physical model. So at this stage, we haven't yet discussed how to go from the narrative to the entity relationship diagram itself, but we tried to master the symbols. What are the different symbols that are used in constructing the entity relationship diagram? What do each of those symbols mean, and why are they there? In the subsequent classes, subsequent lectures, we will discuss the process of coming up with this diagram from the narrative. And once we have this diagram, how to translate it to the physical model that is closer to implementation. And we'll see those subsequently.